For over a century, the popular image of a dinosaur was a slow, solitary, cold-blooded swamp monster, dragging a heavy tail through the mud while waiting for inevitable extinction. That assumption traces back to 1842, when paleontologist Sir Richard Owen coined the term Dinosauria. Translating to fearfully great lizard, the classification focused entirely on their massive, terrifying size. This size-obsessed perspective quickly shaped early museum exhibits. Skeletons were mounted as heavy, immobile statues, locked in stiff postures that suggested they could barely support their own weight. By analyzing only the sheer scale of fossilized bones, early science missed the biological reality of how these animals actually lived. Today, paleontology relies on a different set of tools. Researchers decode behavior by analyzing trace fossils like footprints, running biomechanical simulations, and making direct anatomical comparisons to living avian species. This 24-hour clock maps out our current understanding of the Mesozoic daily routine. By synthesizing modern fossil discoveries, we can reconstruct exactly what these animals did from dawn until dusk. To understand how this lineage survived for 160 million years, we have to look at how they spent a normal Tuesday. The morning begins with small theropods like Mei Long waking up. Fossilized resting postures show these animals slept with their heads firmly tucked under their forelimbs, a biological strategy to trap body heat against the morning chill. As the sun rises, larger herbivores begin to move. Thousands of fossilized footprints clustered together prove that massive species like iguanodon traveled in highly synchronized herds, relying on sheer numbers for protection. For the giant sauropods, breakfast presented a mechanical problem. They lacked the flat grinding teeth necessary to chew, forcing them to strip and swallow hundreds of pounds of raw vegetation whole. This cross-section diagram shows how they processed all that unchewed food. They swallowed smooth stones, called gastroliths, which sat in their muscular stomachs and physically pulverized the tough plant fibers as the animal walked. Surviving the morning required extreme biological efficiency. Every action, from conserving body heat to digesting tons of matter on the move, was highly optimized. A Mesozoic midday was incredibly loud. Moving and managing a herd of thousands of multi-ton animals across a landscape required constant, high-volume acoustic communication. Lambeosaurs and ceratopsians evolved elaborate, hollow cranial crests specifically for this purpose. These skull structures functioned as biological resonance chambers, allowing the animals to project deep, low-frequency calls across vast distances. Physical communication could be just as deafening. Biomechanical models of the giant diplodocoids indicate they could flick their thin, whip-like tails fast enough to break the sound barrier, generating an acoustic shockwave to coordinate movement or deter predators. Maintaining social order and keeping predators at bay in these dense populations relied on a sophisticated, heavy-duty communication network. As the afternoon fades, activity shifts to the nesting grounds. Fossilized colonies revealed that parents constructed carefully spaced, complex nest structures, laying their eggs sequentially over several days to ensure the clutch hatched together. The Maiasaura, a name literally translating to good mother reptile, would spend the evening actively foraging, bringing food back to her nest-bound, helpless hatchlings. As the temperature drops, oviraptorids like sapodi settled over their clutches. They used their broad, insulated feathers to actively brood, trapping heat to keep the developing eggs warm through the night. The ecosystem did not sleep when it got dark. Small herbivores like Eryctodromeus retreated into freshly dug underground burrows for safety, making way for the night shift. This diagram compares the optical bones, called scleral rings, of two different dinosaurs. The incredibly wide ring on the left belongs to the small predator Juravenator. That physical adaptation maximized the amount of ambient light reaching the eye, making it a highly effective nocturnal hunter. From burrowing herbivores to night vision predators, they exploited every hour and every ecological niche. These daily routines were constantly adjusting to massive, long-term climate shifts across the Mesozoic era. During the Triassic period, the planet was dominated by hot, arid deserts. To survive that extreme heat, early dinosaurs adapted by becoming small, lightweight bipeds built for speed and minimal water consumption. Millions of years later, the Cretaceous period brought cooler climates and distinct seasonal changes. In response, some species evolved thick coats of thermal feathers, while others initiated massive seasonal migrations to the poles to find food. Their ultimate survival tool was their behavioral flexibility, allowing them to adapt their biology and their daily habits to shifting global climates. Because they could continually adapt their daily routines, this lineage dominated the Earth longer than nearly any other terrestrial animal on record. We can observe the direct evolutionary link to those ancient routines in modern birds. It shows up in how they flock for protection, how they build intricate nests, and how a bird tucks its head under its wing to sleep against the cold. The daily life of the dinosaur never actually ended. We are just watching a 160 million-year-old morning routine play out right outside our windows.